There have been several types of Whipchecks made available over the years, some of which are still commonly in use. The earliest Whipchecks were a homemade type device, and when used in high pressure applications may fail, causing injury and damage. These sling type Whipchecks may look similar, but the Whipcheck with the hemp string core wire rope failed at less than 1 tonne, while the Whipcheck with the steel core wire rope had a breaking strain of around 8 tonne. However, both failed to suppress the hose whip, as our tests will clearly show. These cable stocking Whipchecks, either in single or double leg, are designed to grip the hose ever more tightly in the event of a failure, and the merits of these will be demonstrated. The final type of Whipcheck is an internal device that has a wire rope sling running internally and secured at each end in the hose tail. While there have been some concerns raised over the potential for these to cause internal wear to the hose, extensive field tests have failed to find any evidence of this occurring. Unfortunately, as there have not been any standards for the construction or testing of Whipchecks, they come in a wide range of strengths and with various manufacturing qualities. As is the case right around Australia, the WA Mine Safety and Inspection Act 1994 places a duty of care on the manufacturers, suppliers and importers of Whipchecks to provide products which are fit for purpose. This duty requires the parties not only to manufacture or supply a product which is safe, but also to test that product and to provide information on the results of that testing to customers. Unfortunately, when the issue of Whipcheck suitability was first examined, no testing had been carried out by the manufacturers. Stage 1 of testing involved ascertaining the strength of various commercially available sling-type Whipchecks and loading them to destruction on a hydraulic test bed. Once this testing was completed, it was considered that the safest outcome was to take the strongest Whipcheck found and apply that to all high-pressure air hoses.
Well, that's certainly better. What did that one fail at?
This one has failed at just under 10 tonne.
Well, I don't think we'll mess around with any of those other ones. I think we'll just go straight for that for the whole lot of them, eh?
Agreed.
Good. Well done.
Further testing was suspended until several more serious accidents indicated a continuing problem. The next stage was conducted as a joint effort between BHP Iron Ore Proprietary Limited and Industrial Safety Advisory Services. It was led by Mr Bob Mulligan, Principal Consultant for ISAS, and Mr Peter Ranissing, Chief Mechanical Engineer for BHP. As the Whipchecks commonly in use at this time, including those that had failed, already conformed to the recommendations contained in a previous study, it was considered that using live air to simulate a hose failure was the only real method of ensuring field-accurate results.
How's the whole thing going to be held down though?
Phil Whitehurst from Metzke Engineering was commissioned to design and produce a test rig capable of restraining a pressurised hose and releasing it on demand. When hydraulic pressure is applied, the cylinder pushes the cam forward, causing the pawls to pivot until the free ends secure the conical surface of the special hose adapters. When the air pressure in the hose is increased and the solenoid valve is activated, the pawls instantly release the hose.